Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Maulidya Anggraini and RP1. Now, I'm a student at Electronic Engineering Polytechnic Institute of Surabaya, majoring Telecommunication Engineering. In this section, I want to share to you about my review paper. The title is Virtual Labs Using Markerless Augmented Reality. Happy watching! Okay, this is my first presentation display. This is my name, my NRP, and my major. Next, first of all, I want to explain that I got this paper from Journal of IEEE International Conference on Teaching, Assessment, and Learning for Engineer, or TALE, which have been happened for until 7 December 2018 in Australia. From this paper, I found a problem. So what's the problems? Many technologies have been used over the past few decades to enable technology-based virtual labs. According to the survey, in the real development of virtual labs and intelligent learning were yet to come. In the case of laboratories involving high-power electric machines, even the danger posed by high power is a matter of grave concern. Okay, next, the case study. Virtual labs. Given in studies the effect of virtual labs in the score in students and conclude that virtual labs indeed improve learning. Previously, there have been using two-dimension method on virtual labs. Following the induction of this idea, various virtual electric circuit simulation software like PSPICE or simulation program with integrated circuit impact, the Microelectronics Web Lab 6.0, Automatic Control Telelab or ACT, which introduced a user-friendly interface for the simulation and internet-based instrumentation control tools, and etc. But two-dimensional virtual labs have a weakness. They even lag behind in providing an interactive learning environment to the user. Hence, the need arose to replace the conventional system with a more interactive and user-friendly virtual lab technique. From the problems, what's the solution can be offered? Next, the solution is using a markerless augmented reality. Why? Because augmented reality or AR is one compelling technology which removes the barrier between physical and virtual environment. Markerless AR was chosen because it is more stable than using marker that will be a possibility of damage to the marker in the future. The present work tries to address this limitation of AR virtual labs by incorporating markerless AR to virtual labs. Markerless AR works on Global Positioning System or GPS, simultaneous localization and mapping or SLAM. Okay, this application was built using platform and programming language that are Android Studio, Unity, Blender, Java, and PHP MySQL. So next, this is user flow how to be built virtual labs using markerless augmented reality. Can start from update AR core data model until experiment result calculate based on input data. Okay, for the example, this is an experiment setup to measure the internal resistance of a DC motor. You can see this is have a full DC ampere meter, and by taking the ratio of the measured voltage to current, we obtain the armature resistance. The calculation is done based on Ohm law. RA is voltage per ampere meter. So next, this is a display on Android applying markerless AR virtual lab to the above experiment. This is a picture shows the smartphone view of the experimental setup. The application was open and using the camera. The smartphone was moved around in search of a plane surface. In figure 3, this is an initial view of Markerless ER virtual lab, and in figure 4, this is a view during the experiment. Okay, after the experiment, this paper have a survey and comparison. The analysis shows that conventional labs are based in almost all the criteria quite understandably. The question here is how close the other two systems get when compared to the conventional system. The survey is trying to identify whether the present three-dimensional Markerless ER virtual lab is better than the computer-based online virtual lab. Okay, you can see in Table 2, Table 3, and Table 4. Table 2, rating for conventional lab. Table 3, rating for online lab 2-dimension virtual lab. And Table 4 is rating for present work. The value is the student preferred 3D virtual labs over the lab experiment in cases of ease of understanding, design, feel, and accessibility. Although the difference is narrow in the cases of ease of understanding and accessibility, the present work is well ahead in all the other aspects. The present work is even ahead of conventional lab when safety is considered. Okay, and the last is conclusion. The work lets the use of Markerless ER to be used for implementing virtual lab, thereby letting the user experience flexible virtual lab experience. The flawless implementation of virtual lab will help numerous number of students to learn and experience lab facilities despite financial, spatial, and safety constraints. This will ensure a bright future ahead for more practice-oriented educational system. Thank you. Okay everyone, that was a little my review paper. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.